So I'm a big believer in data literacy or graphic literacy or data visualization literacy, that we can improve the way people read graphs and the graphs that they can understand. So whether it be fourth graders or undergraduate students or graduate students or business analysts or PhD economists, people can learn how to use and apply and read different graphics. And so a couple of years ago, I got together with a designer friend of mine, Severino Rebecca, who runs the DataViz catalog, which many of you probably know. And we set about to create a kind of a tool, a library of sorts of data visualization types. And so our first project was a poster. This is a screenshot of the poster. On this version of this poster, we have over 90 different graphs broken into 6 different categories. And the idea here is not to provide an answer to which graph you make for the data that you have, because as everybody in this room knows, there is no answer to that question, right? There is no one-to-one correspondence between data types and graph types. But what we set out to do is to create this library for people who may not be familiar with a Sankey diagram or a slope chart or a dot plot. And so we made this poster, and then I started getting emails from people who work in cubicles, and they said, I don't have room for a poster, can you make something else? So we made this sheet on the left, and then we were gluttons for punishment, so we made this flashcard set on the right, and then because I just can't help myself, we made a game, and which is really, it's fun. It's fun. Okay, so I have verification. That was not planted, by the way. But I will give you your $5 later. Okay. So what I want to do is I want to talk about this project, this graphic continuum project, and the challenge of presenting this project to you is that inherently this graphic continuum space is nonlinear and complex, right? Because you could use a column chart, for example, to show comparisons between categories. You can also use a column chart to show changes over time. And so it's inherently nonlinear. And so the way I'm going to try to present it and talk to you about it in a linear format of a presentation is to draw on one of my kids' books. Now, if you have kids, you may know these books. Laura Numeroff is the author. She has many different versions of this. If you give a moose a muffin, if you give a mouse a cookie, if you give a pig a party. If you don't have kids, you should also get these because they're all just great. And what the books do, they all use the same device. They use the same storytelling device known as a circular storytelling device. So in the case of this book, the kid gives a moose a muffin, and then another muffin, and another muffin until they're out of muffins, okay? So then they want to make more muffins, and then to do so, they have to go to the store to get the muffin mix, okay? But to get to the store, they have to put on their jackets. They put on their jackets, they find there's a hole in the jacket. So then they get needle and thread to repair the jacket, and then they decide to make sock puppets out of the thing, and then they paint it, and it's just this whole story, and it all circles all the way back to the moose remembers that he wants a muffin, okay? So that's how this circular story device works. And so I'm going to use this storytelling device to tell you about this graphic continuum project. But I'm not going to use the story of a moose and a muffin. I'm going to use my own version of this story. So here is this story trying to get you to understand how we sort of think about this project. So if you give a nerd a number, he might want a table to go with it. And he could add another number, but we can first focus on that one number. And he could take that number and he can plot that number in an XY space. And he can add another number, and he could add more numbers, and he can add even more data. And this might remind him of other shapes that he could use to present the same data. He might create a stacked area chart, or he might create a normalized area chart. And this might remind him of other graph types that he could use. It might remind him of, a paired column chart or a stacked column chart. And he can rotate the space 90 degrees to, say, create a paired bar chart or a stacked bar chart. And if you were to go back to those lines, he could add more and more data to those lines, right? And this might remind him that he could break this graph up to create small multiples or the dreaded term spark lines. And so he could look just at the endpoints of these lines and maybe think about just plotting those points. And this may lead him to think about, say, for example, a slope chart, which he could rotate again 90 degrees to create a dot plot. And all these decisions that we make about the data and the graphs that we make may lead him to start thinking about uncertainty, which may lead him to think about fan charts, may think about box and whisker plots, or even violin charts. And he could go back to that line chart and he could add a second vertical axis, and this may lead him to think about correlations. So this may lead him to think about a scatter plot to which he could add another variable to create a bubble plot, or the unfortunate 3D bubble plot. And he could think about correlations in lines, and this may lead him to think about other graph types he could use, may lead him to think about a parallel coordinates plot, or use the circles to create a radial chart, or he could combine the correlations with the lines together to create a connected scatter plot to show changes in correlations over time. And this may lead him to think about connections, which may lead him to think about, say, a network diagram, or a force-directed layout, or a hive chart. And the curves in the hive chart may lead him to think about there's a chord diagram. And the arcs in the chord diagram may lead him to think about an arc chart. And he could combine the time from earlier in the arcs in the arc chart to create a sequential arc chart in which time is plotted from point A to point B, B to C, and A to C. And this, very simply, may lead him to start thinking about time, which may lead him to think about a flow diagram or a tree diagram, or very simply just a timeline. And he could take that timeline and he could rotate it 90 degrees, and that might lead him to think about a Gantt chart. And he could take time and familiar shapes together, and he might think about creating a calendar. And he could think about combining the circles from the bubble chart and the time in the calendar to put them together to create a nightingale chart, right? But a nightingale chart is really just a circle that's been exploded out in all different directions, and this may lead him to think about a pie chart, to which, unfortunately, he could rotate, or he could blow it up, or he could punch a hole in the middle of it, or he could blow it up again, or he could cut it in half, but all that's just a variation on a circle, and this may lead him to think about other shapes that he might use to present these data, may lead him to think about squares, for example, to create a tree map, or blow it apart to create a square cloud, or stack them on top of each other to create a unit chart. And the squares in the unit chart may lead him to think about other icons that he might use, might lead him to think about an isotype plot. And the people in the isotype might lead him to think about high frequency data, which may lead him to think about a heat map, which may lead him to think about a contour map, which might also lead to the truly unfortunate 3D contour map. Kenneth, I don't know if you agree. This may lead him to very simply think about maps. And to maps, of course, he could think about adding other shapes. It may lead him to think about circles or squares or lines. And the connections formed by the lines on the map may lead him to think about a specific point on the map where he's currently talking to amazing people doing amazing work in all sorts of different fields. And he could take this point off the map and plot it in an XY space. And so if you were to give a nerd a graph, he might want a number to go with it. Thank you very much.